Hello everyone, this is Thriftysundew back for another video. We're going to be doing a physics series and I'm going to be starting off with kinematics. This is a 1D kinematics equation and I'm going to show you the steps involved in solving it. The problem. Okay, we can start this off with an illustration of the problem. Let's say you are the driver of a high-speed bullet train, like a Shinkansen or something. And for the sake of the argument, let's assume there are windows in this train because you need windows totally for these calculations. So let's say you're traveling at a speed a VI or VO of 30 meters per second. This is your initial speed or what you're starting at. And let's say there's a sheep on the other side, and you hate sheep. You have an absolute hatred of sheep because this sheep has done many evil things in the past, and you absolutely just totally want to destroy this sheep. However, you know that you need to deaccelerate before you hit the sheep because you don't want to like derail or anything. So we'll need to figure out how much we'll need to deaccelerate, how long it'll take us to deaccelerate, or what distance it'll take. So that will be d, or x, depending on what you use. And now let's say we're deaccelerating at 2 meters per second squared. I forgot to put a square here. And let's move on to the variables. So let's start off with what xi is. This is your initial starting position. It'll be 0 meters. Your xf will be, we don't know. It's just basically your distance, because you need to find d, which is xf minus xi. Now let's begin with calculating a, which is acceleration. Should be negative 2 meters per second. And then we need velocity. Velocity initial will be your starting speed, which is 30 meters per second. Okay, 30 meters per second. Vf will be 0 meters per second because you're coming to a stop. Also important to make sure that there's no square here, but make sure to square a. Okay, now we can move on to the next step. The equations and solving the problem. So let's start off with the equations that are used in kinematics, there are quite a few of them, and we're going to start off with the Swiss Army equation. xf equals xi plus vit plus 1/2 at squared. This is very useful for finding the position if you have the velocity and the time. Okay, and then we're going to look at the other equations in case we need to use any other ones. The xf minus xi, or d, equals 1/2 tvi plus vt equation, which is fairly useful as well. Vf equals vi plus at, the definition of velocity of acceleration, a very short equation. And then we have vf squared equals vi squared plus 2ax, the no t equation. Yeah, that can also be d as well. All those are legitimate notations. Delta x, xf minus xi. Now, the most important thing is, can we use these equations? I'm writing is a constant here because we need to check if a is constant before we can use any of these equations. Now, it's negative 2 meters per second, so we're fine. But if no, you would normally have to split up the problem where a is constant, or use calculus, like I write here, which is derivatives and integrals. If not, you can, if yes, you can definitely use the equations. So let's look at what we have. We do not have time, which means we cannot use any of those equations right there. A, B, C. Okay, now that just leaves vf squared equals vi squared plus 2ad, or xf minus xi, you get the point. And let's write it down here. This is where we begin solving it. Now that we've picked an equation and drew everything out, let's write delta x this time. Vf squared equals vi squared plus 2a delta x, representing change in x. Now the final speed is 0. We start out at 30. Square both sides. Plus minus. This will be negative 4 delta x. Okay, we move the 30 to the other side. Negative 900 equals negative 4 delta x. We can sanity check, and then lucky thing is that both sides are negative. That should be delta, but it's fine. So we'll divide by negative 4, and if you can do this in your head, good for you, but if not, I'll put it in the calculator anyways, just to check. Okay, positive 225. meters. Make sure to label your units. Very important. And this equals d, or the displacement that the train went through, and that concludes the problem. Thank you for watching, and I hope to see you next time. Bye.